Hello, you are most welcome, ladies and gentlemen, to Real Impartation Moment on Tuesday Night Anatomy with Daniel Okwen. Today's section, we continue with our general embryology series that we've already begun. My friends, if you are not aware, close to 2 months or so, we've been looking at general embryology as part of the developmental anatomy. So my friends, if you've not watched any of those videos, my friends, you can kindly go in the playlist, okay, called developmental anatomy. Go in there and you find all those videos that I've already done. My friends, today we continue with it, and what we want to look at is to look at the fate of the mesoderm after gastrulation. Yes, we said we will form this trilaminar embryonic disc by way of the ectoderm, mesoderm, and endoderm. We've seen what happens to this ectoderm, okay, by some kind of stimulus coming from this guy we call notochord, stimulating the immediately overlying ectoderm, converted to become neuroectoderm, forming that kind of neural plate which folds and eventually forming the neural tube. And also we saw last week some population of cells at the junction of the surface ectoderm and of course the neuroectoderm, forming what we call the neural crest cells, very important migratory cells, which because of the vast nature of course enormous products or derivatives that it gives rise to, then we're able to call these neural crest cells something we call the 4-germ layer. We saw that last week. So my friends, kindly get all these videos and watch them. My friends, today what we want to look at is that almost simultaneously, yes, there are some substantial changes taking place in, of course, this mesoderm, as those changes are also taking place in, of course, the ectoderm. And what are these changes? The changes will be that there's going to be that kind of conversion or that differentiation of this mesoderm into what we call 3 entities, and I'm going to show you that. So without wasting my time, let's look at what happens to, of course, this mesoderm. So we are looking at the fate of the mesoderm after gastrulation. So fate of mesoderm after gastrulation. That's what we want to look at. And my friends, what are those changes? So the changes will be that we are going to convert this single mesoderm, okay, into 3 components. But make sure that we know the axis. So our axis is the neural tube. Yes, the notochord is also there. So let's, from that concept, okay, and then let's say this is the endoderm. Then we are aware that, of course, the intermediate region will be, of course, the mesoderm. So I'm having the ectoderm over here. This is the ectoderm. And of course, we also have the mesoderm over here. And yes, everyone is aware that the intermediate region over here will be, of course, the mesoderm. The mesoderm is right here. But my friends, one thing that we will see is that, yes, already we've seen our neural tube has formed. So let's say we have our neural tube over here. And of course, those population of cells, okay, on either side of the neural tube by way of the neural crest cells, okay, they are also there, present over there. Now, this time what I want to show you is that this is a tube. You have a cavity. There's the neural tube. Okay, let's say this is the neural tube. And these guys, these are the neural crest cells. Now, one thing we also do not forget is that there will be that kind of rod-like entity over here by way of course, the notochord. Now, my friends, the interesting thing that happens is that this mesoderm, intervening mesoderm, will be differentiated into 3 entities on either side, taking the neural tube and the notochord as the axis. Okay, what we will see, let me bring these guys a bit more closer. by way of the neural crest cells a bit more closer to the neural tube. Okay, so what we will see is that, and using blue to show those three differentiations, I will have this guy over here, one entity here, another one over here, and then another one. So just the same thing over here. Let's say I have one entity here, another one, and of course another one over here. So we have three differentiations taking place right inside, of course, the mesoderm. And what are these things? Taking the neural tube and notochord as the axis of this mesoderm of the embryo. Then what we will say is that this guy over here, this one here, will be called, is very close to the midline. Okay, so we call it paraaxial mesoderm. Paraaxial mesoderm. Paraaxial mesoderm. Paraaxial mesoderm. Now this is very important. Paraaxial mesoderm. Okay, so on the same side, let me call this one 1. So number 1 over here, I also have 1 here. Okay, so this one is also paraaxial mesoderm. Or something we can also say that because it's very close to the midline, that becomes the medial mesoderm. And then when I go to the next one, let me show it from here. That's number 2. Number 2 over here will be called intermediate. It's in between those three entities, so it will be called intermediate mesoderm. Also very important entity, intermediate mesoderm. And my friends, this intermediate mesoderm, one thing I want to tell you is that I've done some videos on it already, will be the one which will contribute to the formation of what we call the urogenital system. So for now, you can put it down over here that it will be very important in forming some of the components of the urogenital system. Yes, that's by way of the intermediate mesoderm. We will come to appreciate all these things. And then you go to number 3. So the number 3 we have over here, okay, the number 3 over here is something we call, let me put it there, number 3 is something we call lateral plate. It's toward the lateralmost entity, and for that reason we will call it lateral plate mesoderm. Lateral plate mesoderm. Very important. Lateral plate mesoderm. So the three differentiations of the mesoderm from medial to lateral. So we are not talking about the axial mesoderm. We are talking about, of course, the first one being, of course, the paraaxial mesoderm. Then we go to the intermediate mesoderm, which I've told you will give rise to some component of course, the urogenital system. And then we also have the lateralmost, being, of course, the lateral plate mesoderm. Yes. Now that's what we see. Now one thing I want you to be aware is that this lateral plate mesoderm, you will see something also happens to it. Something again will happen to this lateral plate mesoderm. Let me show you that just now. Now, this lateral plate mesoderm number 3 over here is that there will be a coelom formed eventually within it. There will be a coelom, and that coelom is the cavity we are talking about. And that cavity will ensure that, let me just make it this way so that it becomes, let me use black to show what is over here, and then the red for this guy. So this lateral plate mesoderm differentiates into 3, also get differentiated. That's what I want you to know, by the presence of a cavity, and that's a coelom within it. And my friends, this coelom will be called intra-embryonic coelom. So I want you to put that point down. The coelom that will be formed, okay, in here will be called intra-embryonic coelom. Okay, intra-embryonic coelom. That's what, okay, will be formed in here. And my friends, by virtue of this intra-embryonic coelom, this lateral plate mesoderm will be differentiated into two. One of them, which is very close to the ectoderm, and for this reason, we will call it somatopleuric. So that we want to put that point down. We want to call it somatopleuric. Okay, so this portion will be called somatopleuric. Now let me use different color to bring out some distinction. So this portion will be called somatopleuric. Lateral plate mesoderm. Somatopleuric lateral plate mesoderm. Yes, I want you to know that. And then the one which is in line with, of course, the endoderm, and for that matter, the yolk sac, which will be very important in forming the viscera, for instance, the gut tube, becoming from, of course, the yolk sac, secondary yolk sac. For this reason, anything which is giving rise to viscera, okay, the word we can use for it will be splanchnic. And that is why this mesoderm, in relation to, of course, this, sorry, here is supposed to be, not a mesoderm, this is endoderm. Endoderm. Yes, in relation to the endoderm, and for that matter, the secondary yolk sac. Yes, this guy over here is related to the viscera, and the word we use for viscera will be splanchnic, and that is why this guy over here, okay, of the lateral plate mesoderm will be called splanchnopluric. Pluric lateral plate mesoderm. So now let's look at what we've seen. We've seen that this mesoderm will differentiate, giving us, of course, on either side, using the neural tube as the axis, para-axial mesoderm, intermediate mesoderm, and of course, lateral plate mesoderm. That's what we've seen. And even this lateral plate mesoderm, with the presence of a cavity, a coelom within it, formed within it, which we are calling that coelom, this time not extra-embryonic, intra-embryonic coelom, we are able to get what we call the one which is related to, of course, the ectoderm, the body wall. Anything body wall has to do with, of course, mesoderm. Somatic, and that is why we call it somatopleuric lateral plate mesoderm. And of course, that portion which is in line with, of course, the yolk sac, and for that matter, the endoderm, we are calling it splanchnopluric lateral plate mesoderm. Yes, these are the things that we've got so far. Now, for now, one thing I want to tell you is that there is a very good way for us to compare. Now, sometimes these things, they come in the exam, you are supposed to tell us what structure is derived from these guys we are talking about. For now, one thing I want you to know is that this intra-embryonic coelom will give rise, okay, to, of course, the ventral body cavities. Yes, I want you to be aware of that. So the ventral body cavities that you've learned already in your first year, where we talk about, of course, the pleural cavity, yes, we talk about pericardial cavity, we talk about peritoneal cavity. These three cavities, which are the ventral body cavities, will arise from, of course, this intra-embryonic coelom. I want you to know that, yes. So that is one useful thing I want you to know. Okay, will give rise to, of course, the ventral body cavities. That's what I want you to know regarding the intra-embryonic coelom. Now, for us to do this very well, okay, today mainly we want to talk about the derivatives of this paraxial mesoderm and, of course, this intermediate mesoderm, which I've told you that is differentiated into, of course, the somatopleuric and, of course, the splanchnopluric lateral plate mesoderm. That's what we want to see. So for this reason, we want to quickly, look at that. What are the derivatives of this paraxial mesoderm, and of course the derivatives of course this lateral plate mesoderm. Now, one other thing too that I want you to know is that this paraxial mesoderm, okay, there will be that kind of regional condensation, that aggregation of this mesoderm, forming some kind of ball-like structures. okay, aggregates of ball-like structures which actually form this time around from in the the distant what do you call it, occipital region of course the head, the future, the destined occipital region, okay, of the fetus, okay, right towards the caudal region, so forming in that kind of craniocaudal direction. And every day about 3 pairs are produced. My friends, those guys are what we call somites. Somites. So I want you to be aware of this guy, somites, because this somites, okay, will be very important in forming some important structures. We can ask you, yes, what are those derivatives of the somites? Yes, so you should be aware of this guy, somite, and then we move on. So for us to do this very well, okay, to avoid that kind of confusion, okay, there are so many derivatives I'm going to tell you, but there's a very easy way for you to appreciate these guys. Because the thing is that once I know the derivatives of this somites, which is coming from this paraxial mesoderm, then indirectly I'll have an idea of what to be derived from this lateral plate mesoderm, having those differentiations, somatoperic and of course panoperic. So that's what we want to see. So let's look at what happens over here. So now, the first thing I want you to know is that when I take one somite, just one somite, this is how it may look like. If I have the neural tube at the other, then on either side, okay, of the neural tube, now I'm taking that we are having this to be the neural tube, just schematically, okay, assuming it hasn't really formed, but let's just take it like this. You have some somites, okay. Now this on the first mesoderm we find will be just around it, and that is the one we are calling paraxial mesoderm. So I'm talking about somites, and for that matter I'm interested in paraxial mesoderm. So my friend, around the 20th day of intrauterine life, yes, on day 20 of intrauterine life, we see the appearance of the first somite. And where did I say to be coming from? To be coming from, of course, the occipital region, okay, of the embryo, the destined occipital region of the embryo. So it will be coming from each occipital region, then it means more cranially. So we are having this as your paraxial mesoderm, and from that occipital region you see some ball-like condensations, okay, formed, appearing to form. Yes, we are talking about starting from the occipital region, okay, and then coming downwards in that manner. Yes, so we'll be forming these guys like this, pairs. And as I told you, we will have about 3 formed per day now, and they will be formed in that manner, craniocaudal direction, from the cranial region towards the caudal region. And my friends, these somites, they are variable, okay, from species to species. We have different numbers, but we are interested in human beings. For that matter, for human beings, when we say how many somites are present, my friends, it's so ambiguous, because the point is we have to know which type of somite we are talking about. We have the first somite to appear, and the first group of somites to appear, okay, will be what we call the primitive somites. Primitive somites. Now, so as I'm saying, from day 20, that's where it begins. And my friends, by day 30, we formed our primitive somite. Yes. And that is why day 20 to day 30 of intrauterine life period is regarded as the somite period. Any other period before it will be the pre-somite, and after it will be the post-somite period. Yes, so day 20 to day 30 is the somite period, so that we form some primitive somites. in the craniocaudal direction. 3 pairs formed per day. And my friends, how many do we have? These primitive somites. My friends, your answer will be 42 to 44 pairs of somites. Yes, 42 to 44 pairs of somites. So the primitive somites, which I want you to put down, will be 42 to 44 pairs of somites. Yes, that's one thing I want to put inside you. Now, these somites, eventually, I'll tell you something, that some of them, the first pair of somites to form in the occipital region, okay, will disappear. And also 5 of the somites in the caudalmost region, coccygeal somite, 5 of them will also disappear. So that eventually the definitive somites, the final somites that we will have, will be, of course, 36 to 38 pairs. So now let me explain that one to you. Now, in the occipital region, the occipital somites, okay, we have 4 of them. Then in the what we call the cervical region, that's in the neck region, we have 8 of them. Okay, then we go to, of course, the thoracic region, we have 12 of them. Then we go to the lumbar region, we have 5 of them. We go to the sacral region, okay, we also have 5 of them. Then when we go to the coccygeal region, we are going to have 8 to 10 of them. Yes, and that is why when we do the calculation, if you are using 8, you are going to get 42 pairs. If you are using this guy, which is of course the 10, then we are going to get, of course, 44 pairs of these, somites. That's what we have. But my friends, as I told you, these guys, some of them, of course, will have to, will be taken away, so that at the end of the day, what is going to happen is that we will have, rather, the first pair of, occipital somites will go away, so that we have 3. Yeah, the cervical region will not change, the thoracic will not change, the lumbar will not change, the sacral will not change, but the coccygeal, what I told you, that 5 of these somites will disappear in the caudalmost region. That is why we'll be having either 3 or 5, 3 to 5, okay? And that's what we have. These will be, of course, the definitive somites that eventually we will have. Now, if I take just one somite, how does that somite look like? Ball-like condensations. These somites initially, okay, they are divided into 2. So the somite is differentiated into 2 areas. Okay, so these kind of ball-like condensations that I'm talking about, okay, we have 2 areas. And what am I talking about? These 2 areas. Okay, let me just say this. Assuming if I take just one ball-like entity like this as a somite, then one thing that we will see is that there will be 2 areas. Yes. So that what is going to happen is that, let me just say that let me take it that this portion, okay, is toward the midline, so that we have the neural tube over here. So take it that this is the neural tube. For this reason, this portion becomes medial and it's also in front. Let's say we are taking an anterior view. That's what we are looking at. Okay, so for this reason, this portion of the somite, okay, will be called the ventromedial portion of the somite. And then this portion further away from the tube is the midline, so further away from it then becomes lateral, and it's away, further away. Okay, I have to go this way, so I'm going to posteriorly. So that becomes, of course, the dorsolateral. The dorsolateral portion of the somite. Yes, that's one thing I want you to know. Yes, and my friends, this ventromedial portion of the somite will be important in forming what we call the sclerotome. And of course, this dorsolateral portion will differentiate into two. And I want you to know that will differentiate into two. And what are these two differentiations? Now, the two differentiations, okay, will be what we call the myotome and of course the dermatome. So it means that initially these two were together at the dorsolateral aspect, and that is why we will be calling it, dermomyotome. So the dorsolateral portion, okay, initially will give rise to what we call dermomyotome, which will eventually differentiate, okay, giving rise to what we call the dermatome and of course the myotome. Now, this is so pretty easy for us to appreciate these things. Because my friends, the point is that when we say myo, it got to do with muscle. Myotome got to do with muscle. And that is why I want you to know that this myotome, okay, is the one which also differentiates. Let me tell you that first. Yes, this myotome also differentiates into two, okay, something we call epithelial myotome, and of course hypophyseal myotome. Yes, that's what is going to be the two differentiations of this myotome. Now, anytime you hear the word myo, it got to do with muscle. So there are some muscles, we call them epithelial muscles. I mean, they will be coming from, of course, this epithelial myotome. That's above. So above the axis, okay, of the spine, above it, okay, the axis being the spine, then we have epithelial muscles. And then, of course, ventral in front, we have hypophyseal muscles. My friends, the epithelial muscles will be very important, okay, or the epithelial myotome will be very important in forming those muscles of the back. Essentially, I am talking about erector spinae. So there's that kind of muscle which helps in erection of the spine, erector spinae muscle, be coming from, of course, this, epithelial myotome. It's at the back. Of course, we said dorsolateral, back. Then we also talk about the suboccipital muscles. Okay, so we have some muscles, okay, we call them suboccipital muscles. Yes, we talk about the splenius muscles, okay, splenius capitis, splenius cervicis, those, bandage-shaped muscles. We talk about them. They are also there. Okay, we talk about those muscles like multifundus, okay, multifidus muscle, okay, we have that muscle. We also talk about, what we call the rotatorius muscle, okay. These are some muscles, we call them, they are derived from, of course, this epithelial myotome. Yes. Then, of course, when we talk about the hypophyseal myotome, yeah, talk about the diaphragm, talk about those intercostal muscles in there, talk about the abdominal muscles. Yes. So those ones will be derived from, of course, this hypophyseal myotome. But in any case, below the head and neck region, most of the muscles, okay, which will, of course, be arising from, of course, this myotome, okay, will actually be coming from the hypophyseal myotome. Yes. So that is, one thing that I want you to know. Now, these muscles, what type of muscles are we talking about? That's the first thing I want you to know. What type of muscles are we talking about? My friends, we are talking about skeletal muscles. Skeletal muscle, that's what we are talking about over here. Yes. And so I want you to know that this myotome, these kind of muscles we are talking about, they are nothing but they are, of course, skeletal muscles. They will give rise to skeletal muscles. Yes. That's what we see. Now, my friends, after that one, then we go to dermatome. Now, the word derm, dermatology, derm has to do with the skin. But don't forget that the skin is made up of epidermis and dermis. We saw last week that surface ectoderm is the one which gives rise to the epidermis of the skin. So it means what is left? the dermis of the skin. And dermis is connective tissue, should be coming from, of course, mesoderm. And what mesoderm are we talking about? It's coming actually from this, one of them, okay, it's coming from, of course, this, somite by way of the dermatome. So what dermis are you talking about? My friends, we are talking about the dermis of the dorsal body wall. So my friends, I want to put down that this dermatome is the one which gives rise to dermis of dorsal body wall. It gives rise to dermis of dorsal body wall. Now my friends, whenever I talk about dermis of dorsal body wall, what I want you to be aware is that I'm talking about dermis of the back. Dermis of the back. That's what I want you to know. So by way of doing some kind of comparison over here for now, I told you that one way to help you remember some of these cells so well is to compare derivatives of the somite, which are coming from, of course, this kind of, paraxial mesoderm, with, of course, the lateral plate mesoderm. So for instance, we've seen that the myotone is giving rise to skeletal muscles. So what type of muscles are left? Talk about smooth muscles, talk about cardiac muscles. Where do you think largely they will be coming from? They will be coming from lateral plate mesoderm. So we are going to see that. So we've also seen that we've talked about dermis from, of course, this, dermatome. Dermis of what? Dermis of the back, dorsal body wall. So it tells me that dermis of the front, ventral body wall, including the limbs, upper and lower limbs, should be coming from, of course, lateral plate mesoderm. These are the ways we do the comparison, yes. Not just simply cramming them, but you have to get the techniques to help you remember some of these things. Now, when we move on, at the ventromedial portion of this, somite, we find this guy over here, which we are calling the sclerotome. Sclerotome. Now, my friends, whenever we talk about sclerotome, which I want to give it a little bit of attention, this sclerotome we are talking about is the one which will give rise to, of course, some components of the axial skeleton. Yes, this is very important. Some components of the axial skeleton, not all. And what components are we talking about? My friends, we are talking about the ribs. That this sclerotome will give rise to what we call ribs. And not only ribs, we also talk about what we call the vertebrae. Bones, okay, that form the vertebral column. So vertebrae. Yes, that's what I want you to know. But not only that one, even the annulus fibrosis of the intervertebral disc. Now, we've seen already that the nucleus pulposus of the intervertebral disc will be coming from remnants of the notochord. We said that. But my friends, the intervertebral disc is not only made up of what we call the nucleus pulposus. Okay, let me just sketch out something. Now, that is what we're talking about. That's the intervertebral disc is having that kind of gel-like, gelatinous, component inside it, something we call nucleus pulposus. Nucleus pulposus. And then forming a rim outside it, something we call annulus fibrosis. So what I'm saying is that the annulus fibrosis component is coming from, of course, this sclerotome I'm talking about. Even the associated tendons will be coming from this sclerotome. Yes. But my friends, one thing I want you to also know is that when I take this sclerotome, that sclerotome is differentiated into three components. Sclerotome is differentiated into three components. We have what we call the ventral sclerotome. We have what we call lateral sclerotome. And then we also have dorsal sclerotome. Yes, I want you to know that, forming all these things. Now, so by way of applying this concept, then when we take one ray, for instance, so let's take it that there's a vertebra. Now, this is a vertebra. Now, you see that there are some processes. I'm interested in just few of the processes over here. Now, this is the body of the vertebra. Now, the body of the vertebra is in front, anterior. That's why it will be formed by what we call the ventral sclerotum. So the body will be formed by ventral sclerotum. Then towards the lateral aspects, we have the transverse processes. The transverse process will be formed from where? Lateral sclerotum. Lateral sclerotum will give rise to, of course, these, transverse processes. And my friends, not only that, even the pedicle and of course the lamina of what we call the forming the arch, okay, forming of course that kind of vertebral arch will be coming from, of course, this lateral sclerotum. Then towards the dorsal, the posterior region, you have the spine, and that is why the spine vertebral, okay, the spine will be formed, okay, from what we call, let me use the arrow right, okay, will be formed from, of course, the dorsal sclerotum. Yes, so that's one thing I want you to know. So for instance, there's this kind of abnormality where the vertebral body fails to form fully. So you may have the left and right components which will have to form, eventually fuse together. So one portion, failure of one to form. Yes. The occipation center failing to develop, and for that matter, failure for the body to form fully. So that we have one half of the body, something we call hemivertebrae. Hemivertebrae. Let me put that point over here. Hemivertebrae. My friends, that condition will be as a result of some problem with the role which the ventral sclerotum was supposed to perform. Yes. And so when you have this hemivertebrae, one thing is that it's a precursor, yes, potentially one of the causes of, sclerosis. Yes, that kind of sclerosis you learned about, one of the causes will be, of course, this hemivertebrae, which, although the incidence is very low, yes, less than 1 in about 1,000 individuals may have this kind of hemivertebrae, condition. That's one thing I want you to know. Yes. Now, these vertebrae, these ribs vertebrae, they are major components of what we call the axial skeleton. So I've seen something where people will write that this guy over here, the sclerotum, okay, will be giving rise to axial skeleton. My friends, there's a catch. Not entirely everything about the axial skeleton will be derived from, of course, this sclerotum we are talking about, and we've seen is, of course, the ribs and, of course, the vertebrae, including the annulus fibrosis and, of course, the associated tendons, okay, of muscles around. That's one thing I want you to know. Now, but how about the ear ossicles? Ear ossicles largely, okay, will be coming from, of course, the pharyngeal arch, the mesoderm of the pharyngeal apparatus. Yes. So for instance, the mid bones, the malleus and incus will be coming from, of course, that the cartilage model, which you call it, Merkel's cartilage. Okay. So the mesoderm of the first pharyngeal arch gives rise to a cartilage model, which you call Merkel's cartilage. Merkel's cartilage. Merkel's cartilage. Okay, and that Merkel's cartilage, okay, is the one which will give rise to, of course, the first two bones, malleus and, of course, incus. Yes. Now, if you go to stapes, everything about the stapes, except its food process, will be coming, of course, from the cartilage of what we call the second pharyngeal arch. Something where it's a cartilage model, what we call it, Ricketts cartilage. Ricketts cartilage. Ricketts cartilage. Okay, so that's one thing that we see. Second pharyngeal, of course, pharyngeal arch. The food process will be coming from something we call otic capsule. So the food process of what we call the stapes will be coming from what we call otic capsule. Otic capsule, which eventually gives rise to what we call structures of the internal ear, which are actually coming. They are ectodermal in origin. Okay, that's one thing I want you to know. Again, when you look at the skull bones, most of these skull bones, yes, with the exception of few of them which will be coming from, these pharyngeal arch cartilages, majority, largely, will be coming from, of course, neural crest cells, secondary mesenchyme. Something we discussed last week, secondary mesenchyme. Except that of the occipital bone. Because the occipital bone, my friends, will be coming from occipital somites. Yes, that's one thing I want you to be aware of. Yes. So these are the things that I want you to be aware, some exceptions I want you to know. So now, having seen the somites, then it becomes very easy because, my friend, the sclerotome is giving rise to some components of the axial skeleton. For that matter, the appendicular skeleton will largely be coming from where? And my friends, your answer will be lateral plate mesoderm. Lateral plate mesoderm. So let's look at the derivatives of the lateral plate mesoderm, which I've told you will be differentiated, okay, into two, somatopleuric and splanopleuric, with the presence of course, the intra-embryonic cilium. So now let's look at that, and we bring our class, okay, to an end, okay, today. So the lateral plate mesoderm, okay, to make it simple, then one thing that we will see is that we will differentiate it so that we have what we call splanchno-pleuric, or let me even start with somatopleuric, lateral plate mesoderm, as against splanchno-pleuric lateral plate mesoderm. Now, keeping in mind the derivatives of what we call the somites. Now, don't forget that I told you that the cilium in between them was giving rise to those structures we call them what? Which form the ventral body cavities. And the ventral body cavities are mentioned, of course, the pleural cavity. Yes. So if you are aware of that, then if you take these cavities, for instance, if you take the pleural cavity, okay, the one which will be forming this cavity will be, of course, the what you call the serous membranes. Yes. And the serous membrane is differentiated into two, so that we have what we call the the visceral layer, and we have the parietal layer. The same way, if I take the pericardial cavity, okay, it's bounded by what we call the visceral pericardium, and of course parietal pericardium. And then, of course, if you take the peritoneal cavity, we have parietal and visceral peritoneal, layers. So exactly, that's what is going to happen here. So that the parietal layers around these cavities we are talking about will become I've told you, body wall, parietal. So for this reason, the first thing I want to put down over here, and somatopleuric will be all parietal layers. So parietal layers of serous membranes. And I've told you already, what parietal layers are we talking about? We are talking about parietal pleura, parietal pericardium, and parietal peritoneum. Okay, so parietal pleura, parietal pericardium, and of course parietal peritoneum. Yes. While of course the sphingoperic is in close association with of course the organ, the viscera. For this reason, all these visceral layers of serous membranes. Yes, exactly what we've seen. So visceral, all these guys. Now let's think about the somites. We said that the somites, there was this kind of, myotome, which was giving rise to some skeletal muscles. So it means that the smooth muscles and cardiac muscles, yeah, they are in relation with what? With the viscera, the organs themselves. Yes. So it will be derived from what we call this, sphingoperic. Yes, that's what we are going to see. So one thing is that these, what muscles are we talking about? We are talking about smooth muscles. And then we also have cardiac muscles. But my friends, I want to put that over here at the cranial end of the embryo. Cranial end of the embryo. Now, I've told you that there is one more thing I will talk about. That will be the last thing for today, which is septum transversum. I will explain that one to you. Okay, I'll put that one over here and explain it to you. Septum transversum. I'll explain this one. At the cranial end, one thing that we will see is that at the cranial end, now I told you the embryonic plates, okay, even cranial to what we call the procaudal plates, which will be the buccopharyngeal, the future opening of the mouth. I told there will be cardiogenic area. So at the cranial end of the embryo, where we have the cardiogenic area, that is where we have these cardiac muscles going to be formed from, and not the entire embryonic plates. So at the cranial end. Now, but the question is it all smooth muscles we are talking about? No. It's not all the smooth muscles that we are talking about, no. Because the point is that if you look at your pupil of the eye, you have two muscles over there. One of them is sphincter pupillae, okay, which is very important. It causes meiosis, okay, constricting your pupil, okay, when there is, too much light. And they also have dilator pupillae, which causes dilatation, okay, so that, in situations where there is, low light intensity. These two muscles, my friends, will be coming from, of course, something we call neuroectoderm. They will be ectodermal in origin. Now, this is a big statement, because the point is that we are aware that muscles should be coming from, of course, these kind of mesenchyme should be coming from mesoderm, but there are some exceptions. The smooth muscles by way of the sphincter pupillae and dilator pupillae will be coming from, of course, these guys that I'm talking about. I'm talking about neuroectoderm. Yes. Now, even ciliaris muscle, which will be very important in regulating the shape of the lens, ciliaris muscle, rather, will be coming from what we call neural crest cells. Neural crest cells. So it means that they are not derived from, of course, this sphingoperic lateral plate mesoderm. Now, let's give more examples. Now, there are some smooth muscles in the mammary glands. Yes. Smooth muscles of the mammary glands. I want you to know. Yes. They are not coming from, of course, this, what's the name? They are not coming from sphingoperic lateral plate mesoderm. Rather, they are coming from what we call surface ectoderm. Surface ectoderm. That's what I want you to know. Yes. Be coming from surface ectoderm. Yes. So that there are some few exceptions. That's what I want you to be aware of. Now, apart from the muscles, we've seen myotome. Then we said we also have what we call, the next thing that we want to talk about dermatome. Dermatome. We said dermatome for the somites coming from parietal mesoderm was giving rise to dermis of the back. So it means that dermis of what we call the ventral body wall, which is in relation with body wall, so it means you should be coming from the somatoperic. So we talk about dermis dermis of ventral body wall and of course that of the limbs. Now the smooth muscles, yes, apart from mammary glands, we may also talk about that of sweat glands. Sweat glands, yes, they will also be relevant in that regard. So dermis of ventral body walls, I mean, I should say these, I mean, smooth muscles of the mammary glands and that of sweat glands will not be coming from spinal cord lateral plate mesoderm, but rather will be coming from surface ectoderm. Ectodermal, that's also another thing. So dermis of ventral body wall and that of the limbs. Yes, that's one thing I want you to be aware of. So now the point is, how about the dermis of the head and face? No, they rather be coming from what we call neural crest cells. Yes, so these are the variations I want you to be aware of. Now, having seen these kind of dermis, then the next one will be, of course, we talk about in the myotome, we talk about sclerotome, axial skeleton. This time around, these kind of bones we are talking about, they are with the body wall. So for this reason, we'll be coming from, of course, the somatopleuric. So bones of the appendicular skeleton, okay? Bones of the appendicular skeleton. Appendicular skeleton, yes. So by way of course, yes, the upper and lower limbs together with their girdles will be coming from, of course, this guy, including, yes, this is a big statement, the sternum. My friends, this becomes a bit, although the sternum is from what we call forms part of what we call the axial skeleton, it is not derived from, of course, the sclerotome. Yes, rather, is derived from what we call the somatopleuric lateral plate mesoderm. So there are some kind of two plates with their own individual spacing centers. Then eventually they fuse together, left and right. They fuse together. So perhaps because they will become from left and right part, then they fusing together. Okay, they will rather become. So let me add that one, including what we call the sternum. Yes. So my friends, these are the things I want you to be aware of. There's the last thing I'm talking about, and we bring our class to a close, will be the derivatives of something we call septum transversum. Now let me explain this concept briefly. Now, the concept is that I told you that the lateral plate mesoderm, the lateralmost mesoderm, okay, lateral plate mesoderm, okay, it will be differentiated into two by the presence of a cilium between them. So take it that, yeah, this is towards with the body wall, ectoderm, so there's the somatopleuric, and then I have this as the splanchnopleurotic, lateral plate mesoderm. Okay, the space between my two limbs will be, of course, the intraembryonic cilium. Now, at the cranialmost aspect of the embryo, okay, cranialmost aspect of the embryo, okay, beyond even the cardiogenic area, the differentiation by the presence of the cilium is no more there. They are fused together. Yes, so that there's no space at this point. They are fused together. So it means that at the cranialmost aspect of the embryo, we don't have the intraembryonic cilium. It's absent. Yes. For this reason, that region, we say there's an undifferentiated lateral plate mesoderm at the cranialmost aspect of the embryo. And my friends, that undifferentiated lateral plate mesoderm is something we call septum transversum. Septum transversum. Septum transversum. Now, it is worth studying for the reason that for now, although we learn other things later about it, I want you to know about these four derivatives of the septum transversum. Yes. And my friends, it's pretty simple. The first one is what we call the fibrous pericardium. Fibrous pericardium. Already, we've seen the visceral and parietal layers of the serous pericardium, which will be coming from, of course, the somatoperic, okay, and then the splanchoperic lateral plate mesoderm, the visceral one coming from splanchoperic, the parietal one coming from somatoperic. But the fibrous pericardium will be coming from the undifferentiated form, which we call a septum transversum. The next one is what we call the central tendon of the diaphragm. Central tendon of diaphragm. You don't just say central tendon, because you may also have central tendon of the perineum by way of the perineal body. So I'm interested. You tell us that is the central tendon of the diaphragm. Now, just below it, we have the liver over there. My friends, this time we are talking about mesoderm. So for this reason, we are talking about the connective tissue of the liver, something called stroma of the liver. Liver stroma. And don't forget this, including that portion of the liver which is hematopoietic. Now, you are aware that in fetal life, the liver is relevant in making these kind of, blood cells. So the hematopoietic cells as well as the kappa cells. So hematopoietic cells and kappa cells. So including hematopoietic. There's someone's name is an eponym, kappa cells. They are the liver macrophages. Okay, kappa cells. And then don't also forget this, ventral mesogastrum. So there's another one I want you to know, ventral mesogastrum. Ventral mesogastrum, which we are going to see, there are a lot of derivatives, okay, which will be coming from it. I'll explain all those ones to you. But one of the simple ones that you are aware of now is lesser omentum. It will be coming from, of course, this ventral mesogastrum. Ventral in front of what the gastrum has to do with the stroma, ventral mesogastrum. We are going to see all these guys. So my friends, I believe you find this meeting helpful. Go on, next week we will delve much into all these individual things. We will explain all those ones for you. I'm very grateful for your time this evening. Have a good night, all of you, and may the good Lord richly bless you. Amen.